At the beginning of 1993, in a new factory just north of Seattle, an assembly line awaited the first components of the Boeing company's latest airliner, the 777. It was a significant moment, the culmination of 2 years' work. Three strips of metal forming the front wing spar for the first plane were being riveted together by a huge computerized tool. By the time this plane is completed, there will be 3 million fasteners like this one, holding together several 100,000 parts. 18 months from today, the number one plane would have to fly. But this schedule was all based on faith. Faith in a new approach to plane making that had taken an estimated $1 billion to develop. Previous Boeing airliners had sometimes suffered from costly errors in the manufacturing process. To minimize such problems, Boeing was determined to improve communications among the 10,000 people who were going to design and build the 777. The company would adopt a new management philosophy, known by the slogan, "Working Together." For the first time at Boeing, this plane would also be designed almost entirely by computer. The inspiration for all this came from an unexpected source. The 777 team leader recalled the lessons learned from assembling his children's Christmas toys.
Fisher-Price does the best job of any toy company on making toys that are easy to fabricate and assemble. Fisher-Price makes a little notch in their wheels so that you only can put the right wheel on the right hub, you only can put the left wheel on the left hub. You also use simple tools. So I started saying, you know, what we're after on this program is not just meet cost targets, not just add value to our airline customers, but we're going to do that by doing what Fisher-Price does on Christmas Eve. We're going to make this easier to fabricate and assemble. So one time as a present, the engineering guys, after we started to incorporate all the producibility, they gave me a whole bunch of Fisher-Price toys so I could pass them out and make the points to the engineers.
The task facing the plane makers was enormous, and the outcome was by no means certain. Pieces of this plane would be made all over the world. In Britain and Italy, Canada, and other parts of North America, Japan, and Australia. And there were two key questions. Would the pieces arrive on time, and would they all fit together as planned? This was a brand new plane, made with new materials, guided by computerized electronic controls, and powered by two of the biggest jet engines in commercial aviation. It would also have the largest rudder in the business, but it was this rudder that would create the biggest cliffhanger of the coming year. The problem started during the design phase. Like all the components, the rudder was designed by a group of engineers called a design-build team. The team included designers and manufacturing engineers, as well as representatives of the company that would make the rudder in Australia. The working together concept was meant to highlight problems quickly and eliminate arguments as the problems were solved.
But legally, for 777 legally...
But tempers rose when the rudder design was changed after the Australians had already begun making it.
Process spec deviation.
Excuse me, what I'm saying is a process is defined right now, and that's what we have to work to.
But the process right now says we've got an X-ray.
That's right.
We're not going to.
Well, I'm just telling you that you have to, you conform to the process as it's defined.
Can't fit it in the room.
Well,
It's not an option.
I'm just telling you, that's something you have to contend with, and that's why, you know.
That's why we want them to buy it.
Not really even close.
In a computer analysis, Boeing had discovered that the rudder might develop a troublesome vibration under certain flight conditions.
You're looking at a 10 to 15% increase in rudder stiffness, or in the total loop stiffness, to solve the problem. I'm going to head down to Australia and face the teeming masses who aren't happy with this.
The teeming masses were the engineers and executives at a small company in Melbourne called Asta. Asta had won the contract to build the rudder. Initially, they were delighted.
It's a bloody big job.
They were much less delighted when they got the news that the design was being changed after they were already underway on the prototype. The rudder consisted of many carbon fiber layers laid in a precise pattern and then baked in an oven. Much of their effort to date was now wasted.
I was cheesed off to blazes because of this change. And I'm not exactly that happy today because we set out to achieve a whole series of things with this particular rudder skin. We'll achieve most of them, but probably the thing that worries me a little bit is that the configuration will change, and it's going to change fairly dramatically. And we still have to deliver on schedule. We've got a requirement to deliver this rudder in the middle of next year, and if we're late on that, it puts Boeing in a bind, and we don't want to do that if we can possibly avoid it.
In any large airliner, the rudder plays an important part in controlling the sideways movement of the plane. In the 777, powered by just 2 large engines, the rudder had a particularly important job to perform.
On this particular airplane, the key task is to allow us to keep the airplane flying in the right direction if we lose an engine on takeoff. It's with a large twin engine airplane, it's a key part to making the whole system work.
The problem was an unwanted vibration involving the rudder and the piston that would move it, called an actuator. Asta was now behind schedule, but the rudder was such a key part of the plane, it had to be delivered on time or it would hold up the whole assembly and testing process. The Asta team met to discuss the situation.
What we really have to address is quite clearly the effect of all these changes that have been brought on to us by Boeing. Lovely company though they may be, they've given us a real problem insofar as building this rudder to schedule, because the changes effectively are the skin gets changed by the addition of something between 2, 4 or 6 strips or plies of tape plus some additional fabric. The actuator fittings in the actuator area become titanium, and there is a whole lot of extra machining on some of the other ribs.
There were major concerns at Boeing over whether or not the rudder would be delivered on time. Any delay could throw the whole plane off schedule. As the newly appointed director of engineering, Ron Ostrowski was worried.
It complicates schedules for certain, because we wouldn't have anticipated having this problem this late in the game. We wouldn't want it this late. So, like Asta in Australia trying to produce the rudder, if we have to reinforce it, it affects them. But these things crop up, you know. There will never be an airplane that's perfect right out of the chute. I mean, it's too complex a vehicle to ever expect that to happen, and changes occur, and we have to just recover from those as they happen.
We've had 2 major redesigns so far, and whilst this one looks good, the previous one, the solutions there looked good. Hopefully this one's better and this solves the whole problem, because after this, I don't know what the hell we would do if there was another stuff-up.
Another design change, or stuff-up as Tyler put it, was all too likely. Only time and further testing would tell. In Boeing's own plant, north of Seattle, a giant machine was lumbering into action to assemble the first plane. Within a 30-mile radius, Boeing had a number of plants that were making various components for the plane. The components would then be shipped to the main plant for assembly. This is one of the largest single pieces of the plane, a carefully shaped aluminum wing panel stretching 100 feet across the factory floor. The plan was that major sections of the plane, starting with the wings, were to be assembled from hundreds of smaller parts, which would be milled and shaped in the various Boeing plants. The larger sections would be transported from where they were built to the final assembly line. Between each of these stages, the growing plane would be moved from one part of the assembly line to another by a series of enormous cranes. In final assembly, the last stage before the plane left the building, the 777 would acquire its two huge engines. But that was still 9 months away. As the first wing took shape, individual pieces were being sealed so the interior of the wing could act as a fuel tank. Glenda Barnes was one of the wing sealers. The working together approach had definitely affected her job, compared to the way things had worked in the past.
I'm a sealer, and if there was a certain bracket, such as this one, that I knew as a sealer that did not need to have seal on it, but the plans as of now said to seal it. Well, before, I would have to submit a request stating why, and then that would have to go from one place to the next, and by then, there's 2 or 3 airplanes that's out the door, but this bracket is sealed. Now, I can pull together with the other team, and I wouldn't have to seal this bracket today. That's how fast some things can happen now. Say after I have done my first 2 processes, then I have to call quality control to come and look at my process. And then they thoroughly go over it to make sure I have sealed in every place that I should seal in. And if I haven't, they will tape it and let me know. And if I have, they will give me the okay to go ahead to the next process. So, I get upset sometime if I miss something, but we all have those bad days and those good days, so, and they are there to find those things that I may have missed.
Boeing calculated that their new methods had meant an 80% reduction in the sort of errors and changes they had experienced on previous planes. The floor beams had come together with an accuracy that was down to the 4th decimal place. They held the seat tracks, which were made of aluminum, except in the galley areas where a corrosion-resistant titanium was used.
The reason it's more subject to corrosion is spillage of pop, Coca-Cola, beer, wine, that type thing. It's very corrosive to the aluminum metals, but not to titanium. You want to make sure that the seat is always held. Whatever in the seat, this is one of our, and I know it doesn't look like very much, but it's a very concentrated area for stress when the seats, in a crash load or something like that, it's very difficult. And you have to make sure that you can survive a 16G crash.
In the past, the designers in their offices would have designed a component and then washed their hands of it once the drawings had gone to the factory floor. Now, they were involved throughout.
That's really interesting there. We have some manufacturing engineers working with the mechanics. Now, these guys are from the office building, the engineers from over there, and they're coming out talking to the mechanics, something that you would never see in the past. It is absolutely the only way of doing business. Before, I couldn't find an engineer, and now today I have to ask them to leave so we can build. They have to just quit designing so we can build.
The floor beams were made of carbon fiber composite, very light and very strong. A guiding principle in the design process was building a plane that was as light as possible to minimize fuel consumption and reduce running costs. Wherever possible, the team looked for lighter materials that could substitute for more conventional ones. But in one case, this got the 777 team into trouble. The design of some parts of the plane called for using a new metal alloy called aluminum lithium. Aluminum lithium was to be used in a whole range of areas in the plane. It was expensive, but it was also much lighter and helped the plane meet its weight requirements. But long after the decision had been made to go with the alloy, they discovered a problem. The new metal developed small cracks when it was drilled.
Cracks are a very sensitive issue, as you can imagine in airplane design, because we go to great lengths to not only not have cracks, because cracks usually mean that the crack can propagate or get bigger. Plus, we go to a lot of detail to make sure that if a crack does get started, that we have ways of stopping the crack so it doesn't grow. And it's just part of our normal design process. The The issue we had with aluminum lithium is that for the applications we were using it, the cracks were okay, technically, but you could see the crack. So how would the customers feel about that? They could see the cracks. Now we'd have to say, on these parts, Mr. Airline, the cracks are okay. And they would have to figure out how to communicate that to all the people that interface with the airplane.
It was time for a decision. Already, the factory was preparing to manufacture parts with aluminum lithium. A meeting was called of all the engineers involved. Before the meeting, the halls were buzzing with rumor and comment.
They're talking about cancellation costs of like $2 million for a bunch of the applications we're talking about.
And I think on the aluminum lithium meeting, we all had both opinions in our minds at the same time. It'd sure be nice to just go ahead and get that weight in the bag and done. It would sure be nice not to give the airlines and ourselves an extra problem. So you got to be very careful not to make up your mind and let all of the different sides of the issue get out in the open, and then collectively use your strength to make the decision. So the way we try to get the best decision is to get all the pieces out on the table, see what's new, see what that means to us, can we do something about it or not? And then usually that thorough discussion leads you to the right direction.
You're going to have parts here that sooner or later it's going to be discovered. Major or primary structural components like Section 12 rib stiffeners, which the airlines for 30 years or 35 years, whatever it is, when they find a crack, they figure they don't fly till it's fixed, and it's a whole, I don't know how big the crack's going to be after 5 years or 10 years, whatever it is, but you have the potential here of developing multiple numbers of parts that are going to have minute cracks in it, and to the airlines, that's not an acceptable structural configuration for the airplane.
It's acceptable if Boeing says it's acceptable.
Well, you've got a basic material characteristic you know about already. For example, you know you can't use it in sheet. You know you can't use it in plate. You know you can't use it in some kind of extrusions. 2 more just fell off for whatever reason. You know, the handwriting's on the wall. It's just something that I think you need to listen to.
Well, the data's on the wall.
The data.
Maybe I'd like to say a few words since Brian has had a chance to talk about this. The fact is now is that from a technical point of view, I would not put this back on the airplane if I had a choice, because we know more than we do now when we made the decision. On the other hand, I do remember that 280 pounds is still an extremely valuable weight saving for this airplane. And if we take this 280 pounds out, then I don't know where I'm going to get it. We've worked extremely hard to save weight, and we're going to continue to work hard to save weight. And so it's a balance.
Yeah, I think everybody here is aware of the big issues. I mean, it's going to come down to cost and weight versus economic risk.
There's an economic risk, and the worst thing is having to explain this to the airlines forever. I think that's the problem with the preferred airplane.
But it's not black and white, and
Right.
and if we were 12,000 pounds ago, it'd be a different situation than we are today.
The decision to remove the aluminum lithium emerged almost by stealth, as the group moved imperceptibly from discussing what would happen if they removed the alloy to planning how they would manage without it. Mullally had achieved a genuinely unanimous decision.
We are tightly bound together.
Nobody said this would be easy, right?
Creating solutions and balancing of objectives.
The fact is, it was a good decision. There's no question about that. Again, we thought of the customer, which is what we ought to always think of in decisions of this kind. In this case, the material exhibited certain properties that we didn't think were acceptable. And it wasn't a safety issue at all, but it was a quality perception relative to those imperfections. And we decided until that material had those imperfections removed, we just didn't feel it was appropriate to put them in the aircraft. So we did.
The repercussions of the aluminum lithium decision were to rumble on for a long time, with particular significance for the work being done in Japan. A group of Boeing managers, led by Vice President Neil Standall, traveled to Japan to visit several companies that were making parts for the 777. The trip was a mixture of corporate relations, making the Japanese feel appreciated, and checking up on the parts that would soon be needed in Seattle if the plane was to stay on schedule.
It takes, as you well know, a lot of capacity, both in people and in equipment, to build an airplane. So you want to spread that, if you can, across good foundation or good suppliers. The other reason is for sale benefit, like in dealing with Japan. They buy a lot of our airplanes. They're the biggest buyer of the 747, for example. So we want to have a relationship with the Japanese.
The Japanese were manufacturing 20% of the parts for the 777. Some of these were supposed to have been made from aluminum lithium, including key components of the wings called in-spar ribs. Nippy, the company making the ribs, had scrambled to redesign their machine tools so that another metal could be used. These trips turned executives into 24-hour-a-day workaholics. Business and noodles became hopelessly intertwined. The group was thinking ahead to its visit to Nippy just 2 days away.
I have the materials for Nippy in my briefcase.
Now, when did Nippy ship the in-spar ribs?
On the 30th.
Have they arrived in Seattle?
Yes, they have.
I saw it. I like that.
You can eat sushi with fingers, too. Try it sometimes, it tastes better.
I've ruined 26 neckties, and now she tells me I can eat with my fingers.
You bring the bottom end up, and then it doesn't slap around.
I see you slurping. Let's all watch Neil slurp it.
Want me to do it?
I want you to do an extraordinary. Not all those. You'll never. Wait a minute.
I bite them off.
No, you're supposed to slurp them. Oh, look at that.
Now I know why you got to be a vice president.
Yeah.
Couple more beers.
Junkie Datsu.
I encourage you.
Many people, including some employees, wondered why Boeing had involved the Japanese at all. Building large aircraft was one area of technology the Japanese had not yet developed. Yet here was Boeing operating on what some people called an open kimono policy. But for the 777 team, this collaboration provided access to high-quality heavy engineering and equipment. Kawasaki had constructed an entire factory just to make parts for the 777 fuselage, and part of the purpose of Standall's visit was to attend the opening ceremonies. No such occasion could be allowed to pass without a Shinto religious ceremony. This was a significant event. A priest might receive several $1,000s for a service like this, in the hope that the gods would look favorably on the machinery and ensure that it ran smoothly in the years to come. While Standall looked out of place with his Japanese colleagues, he had done his homework when it came to joining in.
Good job. Bye. Did you get your little cedar box?
No, I didn't.
I'm going to take this home for my wife for an Easter gift. We don't get a chance to go shopping, so this is going to be your Easter gift. Somebody took my original one, so I went and got another one.
The next stop was a visit to see how things were going on the passenger doors. The new design methods had made it possible for all 8 doors on the plane to have many parts in common, which saved time and effort in the manufacturing process. In their relations with the Japanese companies, Boeing had to take careful note of the cultural differences between Japan and America. As Standall and his colleagues toured the various factories, they sometimes found problems that had to be dealt with as tactfully as possible. One of these became a worry.
About a month ago, we discovered a problem, brought it to their attention. They told us what they were going to do to resolve it. Things weren't happening. We met with them last week. That was one of the reasons we came over early. They showed us what they were doing, and it was unacceptable. We expressed our concerns to them, told them what was wrong. We had our people work with them on again, off again during the week, and we were not getting anywhere on resolving this. So we asked for a meeting with the general manager, and that meeting could have been very difficult. And as it was, and I couldn't sleep because I was worried about it. Mr. Blakely was worried about it. Neither one of us slept well. And we went in the meeting, had a good open discussion, and so we were relieved. But it could have been, what next if we, where do we go next if we fail here? So we were worried. And I think that, that speaks of the relationship we want to have with them. If we were whimsical and didn't care, we would have gone to bed and gone to sleep. But we care.
The following morning, the group visited Nippy in Yokohama. While the bus was on its way to the plant, the workers were already in the middle of their compulsory morning exercises, surrounded by the 777 in-spar ribs the company was building. Standall's visit to Nippy was partly to thank them for staying on schedule in spite of the changes in design and material. He presented the company with a certificate of thanks from Boeing's senior management. As Standall and his colleagues left the factory and headed back to Seattle, they had mixed feelings. Satisfaction at seeing how well the Japanese had learned how to build airplane parts, mingled perhaps with concern about how long it would take before the Japanese would be building airplanes on their own. In Australia, things were going badly with the rudder. The much-feared stuff-up had happened. Boeing had decided on a third major design change to compensate for the rudder vibration. It was another major setback for ASTA.
We've got a lot of major tools either completed or nearly there. And this last change is probably going to affect at least 65% of our tooling program, and we've got some 600 tools. Anywhere from the large layup mandrels like you've seen to some of the big, huge assembly jigs to put the thing together. And it changes a lot of it.
To soften the blow, Mike Voetland from Boeing arrived to explain the changes in person. It was a difficult job at best, but it was made worse by the fact that Boeing's engineers were still tinkering with the design as he was flying to Australia.
I think we need to have a telephone conversation with Seattle to find out between the time we left and the time we got down here if there's anything that's changed.
Yeah, we can.
Now the bad news is, as you all know, we don't have a lot of time left. And I looked at the schedule last night when we got in, and it tells me that we have about 5 months and 3 weeks to complete this hardware, which is a task that I would say under normal flow conditions would take about 18 months. So we have quite a challenge ahead of us here because the rear spar.
As the Boeing people laid out the changes, it became obvious to ASTA that their worst fears had been realized.
Are you going to change that rib as well?
It looks like worst case, we hit this rib, and the rear spar. That's the bad news.
That is bad news.
Now there is an attach plate up here, but we didn't quite have the details worked out before I left.
When we all came back from the holidays and we thought we had a nice smooth sailing program once again from the last change, they told us, for instance, several of these parts weren't changing, absolutely not. And so we've rescheduled the program based around that particular assumption, and now, just today, we find out that some of those major tools are changing. The addition of this fifth hinge, the changing to those rear spar mandrels and whatnot, is a big impact. It's going to be an interesting one to manage in the time frame.
Are we going to live with April the 5th?
Sure.
You will. I'm sure you will.
That's a month after we asked for it.
Come on, you guys have to give me some. Man.
Yeah.
You guys are just... What'll happen is...
We're going to give you a rudder if you're lucky.
Boeing had to keep the pressure on ASTA. The delivery date for such a key part of the plane couldn't be allowed to slip, since it would jeopardize the whole 777 project. But Voetlin was clearly worried that ASTA would not be able to keep to the new and punishing schedule.
What are you now saying?
Problem is, the magnitude of the workload is enormous, and the opportunity for things to go wrong is great. And that's why I say that I am maybe a little more pessimistic than what you might hear from ASTA.
Boeing has to have respect for a small company that's essentially, I don't want to say bail them out necessarily, but certainly help them out of a bind. I don't know as Boeing could get through one of these changes like this late in the game in-house on their own program.
The schedule is based on...
Back in Seattle at the regular critical issues meeting, as it was called, the team was going over the myriad problems that threatened the already tight schedule.
Probably the single biggest item that we're trying to do now is number, whatever it is, 12, panic early.
At each meeting, the team analyzed the case histories of things that had gone wrong.
We looked at our payloads, we looked at our systems, now we'll look at the structure. And I think Wolf made a good point, which will start to show up in these next two, and that is you miss your first commitment and then things start to go wrong. Here's an example of a fuel jettison system, and find all the pieces here. When they got around to do the installation, somewhat late, there was a problem. This will not accept the vent tube.
The issue there was that the engineers had a design and they'd actually ordered the parts to build it. Okay. Yeah, it's really just a tube that comes out of the outboard end of the trailing edge, and it enables the airplane to dump the fuel should it need to return to the airport. When they came to work the installation, which involved other interfaces, then they realized that the details and assemblies that they released prior to that time had in fact an interference problem.
They discovered at the assembly stage that a piece called a nut plate interfered with the fasteners on the vent tube, exactly the sort of thing the new design techniques were supposed to prevent.
What would it tell you to do or emphasize for the future?
Ideally, you'd model in all your fasteners and the nut plates, ideally. However, secondarily, if you work to the schedule and not give up time, that there is more time to recover. Here we've had a situation where we didn't get the installation done, and so the surprise came later. And now it's so late that we're out of sequence.
Yeah. There's enough detail in the definition as the installation's being built up that the engineer, if he's really paying attention to it, knows he's got a nut plate there. Maybe he's not modeling that nut plate, but if he knows he's got close interferences between parts,
he has to deal with it.
He has to deal with that.
Or he doesn't have any
and he needs
solution.
to model it in that case.
So our long-term hope is that every designer with his ME counterpart gets it to the place where they have an integrated solution, and only they can tell us that, because they're the only ones that know those pieces going together.
Yes. And we had to address that so that we know who's been there. There's a clearinghouse. At times I sit in meetings, and even now, I get thinking from time to time, boy, back on the 767 or back on the 737, this is what I did and it worked, and I get impatient, I want to pounce. And yet with the style we have and the team that we have, we are all in this together. We support one another. We don't pounce on one another. I can remember incidences on other programs where various functions would just be at each other. The parts weren't here and the manufacturing guy needed them, or the design wasn't done so the planners could do it. And they'd be across the table at each other just talking very loud. And I've seen that over many times in my career. And when you sit and look at the style we use, if he's got a problem, that's my problem. So let's go work it.
What do y'all think of Jerry's work?
How about his team?
Huh?
Midway in the year, there was a meeting of the whole 777 team. The only place that 10,000 people could assemble was in the factory, on the very spot where the first 777 would roll out of the building in 9 months' time. The occasion was a reminder of how patriotism and plane making went hand in hand.
How are you? Hi, how are you?
Good. Morning, Mr. President.
How are you?
Now, will you please join me in welcoming the 777 Division Vice President, General Manager, Alan Mulally.
So good morning to you all. This is the 9th all-team meeting that we've had on the program, and we've come a long way together. It's been 21 months since we launched the 777 with our order from United Airlines. We only have 8 months to go before rollout. We are going to turn power on the airplane in January of next year, with a first flight of June of next year. So it's really coming together fast. Today, we thought it would be really...
At about the same time as the all-team meeting, there was another milestone in the life of the first 777. A whole wing was going to fly, out of the jig in which it had been assembled and across the factory floor. It was 2 weeks later than planned, but everyone hoped they could make up the time in the months ahead.
Well, you better see if they all freeze. I just raised some tape in around that. Pop it up. Let's just hang on now. Let it go down. No, we've got half the distance down.
Before the wing could be lifted, it had to be freed from a series of fixtures on the tool, one of which was proving difficult.
They're going to be a couple minutes, aren't they?
In this high-tech factory, it was a hammer that finally did the trick.
We need to be careful that we don't hurt somebody's finger in pulling that out or damage the tool itself. So we want to be cautious as far as how we drive it out. And right now we're using a smaller drive pin, and it just freed up. That popped, and now she's done. So that's good news.
Our crescendos one after the other. This just happens to be another one subsequent to that one in January where we loaded the spar. Now the wing. Tomorrow we'll load the stub and the keel beam. So we're just one right after the other now as far as the first airplane is concerned.
This is our last locator. Let's go on back over to our positions along the wing again now. We need some people in the mid-span here. Going up! Coming up!
22 on. Okay, this SOB kicked about 4 inches north here at the top edge.
North. Oh, lovely.
The first inch was the hardest. From then on, it was slowly and steadily upwards.
Everything's went real smooth after we got it cleared from the tool. It was smooth pull, smooth transition coming over. Both the cabs are working real well together. There's virtually no movement in the wing when they simultaneously move, and that's a good thing to see. We're almost done. We're on the road home. We see the light at the end of the tunnel.
Looking good, Don. Perfect. All right, good job, you guys. There it is, first one. Woo.
While wing number 1 was on its way down the assembly line, more wing components were headed for the factory to be assembled into planes farther down the line. Today, at the Auburn factory, one of the long wing panels emerges and emerges and emerges to be trucked to the assembly plant 60 miles north. There were huge logistical problems in getting pieces like this to the factory just at the right time. Not too soon so they took up storage space, nor too late so they held up the process. Like a dinosaur with a second brain in its tail, this 130-foot-long truck needed a driver at each end. There was also a third driver and a van behind to prevent nasty accidents.
I'll pick you up after him, huh?
As accidents on the road involving other vehicles and stuff, we've never had. So that's pretty impressive right there. We've had a couple incidences with just stop signs and stuff, but other than that, nothing.
One there in the left lane. Okay, ready, thanks. I see it back there. Keep an eye on him.
Oh yeah, we've had people dynamite their brakes in front of us, so we had to go around them real fast. We had a Porsche that was going to go underneath of us one time, and then we had a motorcycle decide he was going to try it one time, but they quit real quick.
Boeing has other plants across the country. A big plant in Wichita, Kansas made several key parts for Boeing planes that were shipped by rail across the Great Plains to Seattle. It was never a trip without hazards.
One of the problems we've had in the past is on our 737 aircraft that we do not cover. We do not cover the rail car. We've had rifle shots. We've even had an arrow stuck in the side of the fuselage when it was received in Renton. We've done things a little different on the 777 where we actually cover the rail car, so we hope to prevent some of that, although a rifle shot would still go through probably that covering, but there wouldn't be the extent of the damage that we've had on the other aircraft.
More and more parts were being assembled into bigger and bigger pieces as the major sections of the plane began to take shape. The pieces were held together with rivets, fasteners that would hold them to the ribs and cords that gave the plane strength. This was the largest automated riveting machine in the world. It was controlled by computers. But automated riveting wouldn't work for parts that were too curved or awkwardly shaped. These would be done by hand.
The best things about this job are I'm compensated very well, really, and the atmosphere overall is fairly relaxed. I don't feel really stressed or really pushed, and that's real important in any workplace. The worst parts of it are probably that at times it does get tedious, it does get repetitious, and it gets a little noisy in here. The environment isn't always real pleasant, it gets a little warm sometimes. That's probably the worst end of it. There are some mechanics that don't like to work on the exterior skin of the airplane because it's easy to destroy thousands of dollars worth of material in a very short time if you're not careful, and some of them just don't like to probably take the responsibility of maybe doing that.
Before complete pieces of the plane left the factory, they underwent an important procedure called an FOE check. FOE for Foreign Object Elimination. Boeing wanted to avoid having a customer find anything rattling around in the plane after delivery. A second set of initials, FOD, refers to foreign object damage. It wasn't a complicated procedure. You tipped a piece on end, banged on its sides, and hoped any loose objects fell out. One did.
We know by analyzing it that the bolt came out of our major assembly area, that in their FOD check they missed it. The pins are probably out of our secondary forward box structure area. That information will be fed back to the mechanics who run the process in those control codes, in those assembly areas.
On the other side of the Pacific, in Australia, the progress of the rudder had reached a more hopeful stage. In spite of all the design changes, the rudder for the first plane had been completed on time and was about to be shipped to Seattle. But there were still one or two tiny problems, like rounding up some missing fasteners.
We're now down to 6. 3 are on their way on an aeroplane, and 3 are probably at this stage being put on an aeroplane to get here in time so that we can fasten them up on Saturday.
Boeing wanted to get their hands on the rudder as soon as possible. They arranged to fly it to Seattle on a 747 freighter. Mike Voetlin of Boeing was in Melbourne to keep up the pressure.
Well, we wanted to, one, come out and congratulate ASTA for the tremendous job they've done. 2, we have some issues that we have to clean up this week.
Money.
And, a variety of contractual issues. And we also want to see the hardware ship out the door. We've been involved in this now for 3 years, and this is kind of the culmination of a lot of effort by a lot of people, and we'd like to see the end of it.
We had to design a special shipping container for it. We went out to the airport and measured the door, and we have to cant the rudder at a 45-degree angle and support it in a special way, and push it into the airplane, and then we bring it into Los Angeles, and we have to put it on a truck and truck it up to Seattle on an air ride trailer.
Just when it seemed to be going smoothly, there was a final snag. The rudder in its box bashed a small hole in the ceiling of the freighter. Another first for the 777 began one Sunday morning at 6:18 a.m. The first 2 wings would be lifted into position side by side and attached to the central piece of the fuselage. It would be a crucial test for the new computer-controlled crane system built especially for the job. There was an air of uncertainty about the center of gravity of the wings, since they had acquired a lot of extra weight over the previous months.
We put some extremely heavy components on this wing. We've hung the nacelle strut. We've got the aft diagonal brace installed. We've put an awful lot of systems, not only on the trailing edge and on the leading edge where you can see it, but we have folks that work every day inside the wings, putting components inside the wings. We've got a lot of fuel filters, we've got fuel probes, we've got hydraulic systems, we've got fuel tubing, we've got electrical wire runs inside the wings where you can't see the things that have been added on. So that changes the weight and the balance of the wing from the time that it moved from the seal test and paint area, and then we pick it up with all of these added components, and it changes the center of gravity.
No one had ever lifted this much weight with these cranes. Bugs in the computer software began to cause small imbalances in the tension on the 4 hooks, which then caused the crane itself to cut out. Bags of lead shot were used to even out the tension temporarily, but more work would have to be done on the software as soon as possible.
Line yourself up east, yeah, inward. East and west here. We're going to hold this for a few minutes while they wipe all their ball sockets.
Once the wings were in position, they were bolted firmly to the fuselage. Then a final quality control check for tightness. Near the end of the year, the 777 team met to celebrate a symbolic milestone. It was the 777th day of work on the new plane. The team permitted themselves 3 quiet cheers as they looked ahead to what the new year would bring. As the first year of manufacture drew to a close, the 777 team breathed a sigh of relief at the progress they'd made. But what they had done so far would later seem simple compared with the upcoming task of installing and testing a whole new range of hydraulic and electronic systems. And then would come the testing of the 2 huge engines that would have to lift the plane off the ground. Time was of the essence, for now that first flight was just 6 months away.